this is technology. So as you can see, with my background, there is snow up here in Montreal. The temperature is quite warm. We have about minus 15 degrees Celsius, so it is quite warm, because earlier this week we had minus 20 and minus 25 degrees Celsius. So if you ever come to Montreal in wintertime, don't forget to bring a coat. Okay, having said that, you see the title of my presentation. I'm going to talk about quality assurance, software quality assurance, and also the ISO standards for which I am the editor. So the presentation we'll have today will have the following topics: an introduction, then a description, an overview of software quality assurance, a description of 29110, and 29110 is a standard that has been developed specifically for small entities. And what do we mean by small entities? We mean organization having up to 25 people. So it could be a team, it could be a company, it could be an organization, okay, having up to 25 people. And then a very important part of my presentation, I'll show you a real example of a real company that ignored the practices, the proven practices of a software engineering standard, and you will see the impact, the negative impacts of that. And if I have time, I'll talk briefly about the survey that we did, and then we'll finish with the conclusion. And at the end, we'll have a question period. So if you could, please note the number of the slide, such that when you ask the question, I can display the slide again, such that everyone is on the same page. If I can use this expression, and I'll let you read this. So this is a point I want to make today. Very important point. As I've been working in industry for about 50 years, and that's the point to remember. If you're smart people, you'll be learning from the mistakes of others. Okay? You will not be repeating the same mistakes over and over again. So let's start with the introduction. A few words about myself. I've been working at the Department of Defense, and I was the project manager to establish a master degree in software engineering in 1988, and also a software engineering center somewhere in 1889 or so. And then I switched to work for industry, and I was the project manager to put in place and improve the software engineering processes, the system engineering processes, and the project management process. Then I left Oerlikon Aerospace, and I did some consultation for transportation companies and the subway of Montreal. And in 1999, I was invited to join ETS. ETS is an engineering school in Montreal. It has about 12,000 students that are studying engineering. And also in 2002, I became the Delegates of Canada on ISO, and I became the editor of 29110. And one of the things I was invited in a few universities, but just to list one, I was invited twice to give the software quality assurance course at the Chiang Mai University of Thailand. Okay, that's about myself. Oh yes, I forgot. With a colleague, I wrote a few books. So on the left side, if you're fluent in French, you see the software quality assurance book 1 and book 2. And on the right-hand side, you see the recently published software quality assurance book published by IEEE in Wiley. And the good news is, if you're a member of IEEE, or if your university is a member of IEEE, you can download the book, all the chapters of the book at no cost from IEEE. Okay, let's go with the first question, which, if you see this, you'll say that's a stupid question. Everyone knows the answer to this question. I have a surprise for you. So depending on your point of view, and this also impacts, okay, the point of view also impacts the way you see quality assurance and the way you apply software engineering standards. So if you are students, you are writing some code, and after a week or a month or after the semester, your code or your software will go in the recycle bin. Okay? If you are working in a small company, then you may also have a partially tested code. But if you are working in an organization that will be using or maintaining the software for a few months or for a few years, then you will need also some documentation to support that software. And the last category, and this is the category with which I worked for many, many years, category of organization that will be using the software for many years and also for many decades, 10 years, 20 years, 30 years, 40 years. So you may be surprised when I say 30, 40 years because most of you are not even that old yet. Okay? So those are the type of products that will have a lifespan of 30 to 40 years. And just as an example, the banks. So some software written back in the 1960s and 1970s in a language called COBOL, they're still using it today. So they have tens of millions of lines of code written in COBOL, so they have to maintain that software because it works. Okay. Another example, if you have a small car, okay, then you probably have, when I say a small car, but let's say a recent car, a car that was produced during, let's say, the recent 5 years or so, like a Toyota Corolla or those things, then you probably have about 100 microcomputer and 100 million lines of code. Same things for small pickup trucks. They also have about 100 microcomputer and 100 million lines of code. So those guys that developed and maintain that software, because you can imagine that the software that has been developed for cars in, let's say, 2 years ago will be improved and will be maintained and will be reused over and over again for the next 5, 10, 15, 20 years. Okay, because the life of a car is about 15 to 20 years, depending on the country. And also the software that has been developed, let's say, for the braking system, will be reused over and over again in the future models. Okay, so those guys have a different perspective about the definition of software, and this is what they mean by software. So what they mean by software is all the documentation that has to be developed, maintained, updated for 10 years, 20 years, 30 years, 40 years. Okay? And as you notice, code is only one small part of that information that is produced during the development and the maintenance of a software, either a software product or software components embedded in a car, a train, or a plane. So for the people that are working with at the upper level of my slide, what I call that the computer science mindset, where it's mainly about writing and testing code. Okay? And while for the people working at the bottom of my slides with systems that'll be in operation for many decades, they are developing and maintaining a product. So it's a completely different mindset. Okay? And this is why the application of software quality assurance and software engineering standards varies a lot depending if you're working from the top level of my slide or if you're going down and working in an organization that will be developing systems or components that will be in operation for many, many, many years. Okay, having said that, those are the challenges facing software developers. But my message here is this is priority one. Okay? This is priority one because of this reason. Okay? If you set quality as priority one, then you are increasing the chances that you'll be delivering within budget, within schedule, and things like that, right? Okay. So I'll give you two definitions just to make sure that we are on the same page. The definition comes from a standard, okay, because we don't want to reinvent terms. Terms have been discussed, they have been published in standards many, many years ago. And this standard that I'm showing you is the IEEE 730 standard about software quality assurance processes. It's been published in 2014, and presently there is a revision of that standard, and somewhere in 2025, a new version should be published. But anyway, the definition won't change. So it says, first, software quality is a degree to which software product meets established requirements or the requirements established by the user or the customer. But, however, quality depends also on the degree to which the requirements accurately represent the needs of the stakeholder, the needs, the wants, and the expectations. Okay? And what do I mean by that? The needs, the wants, and expectation, you have the definition at the bottom of my slide. Okay. So there are things that the customer wants absolutely, and there are things that the customer would like to have. And if we have time and budget, there are other things that could be very interesting to have. And also, what we mean by stakeholders are all individuals that have an interest in the software. So it's not when we say the customer, who is the customer? Is it the person that paid for the software? Is it the person that will be using the software? Is it the person or the group of person that will be either using or maintaining the software? So those are different perspectives. Those are different stakeholders that have an interest in that software product. And the next definition is about software quality assurance. And it says here, it's a set of activities. So you see that I've put in bold the word a set, because software quality assurance is not just testing. You will be surprised, and I'm still surprised to see even now in 2025, that many organizations, when you talk about software quality assurance, they say, oh yes, we're doing tests. And I say, yes, but what else are you doing? Oh, we're doing unit testings, we're doing system testings. I said, yes, okay, I understand. But beside tests, what do you do to provide, to do software quality assurance? And they don't know. They don't have the answer. Okay, let's continue the definition. It says a set of activities that define and assess the adequacy of the software process. In other words, if I'm building an application for telephone, the process is quite different than if I'm building the software that controls the engine of an aircraft, right? So is the software process adequate? And also, the activities of software quality assurance will provide evidence or proofs that will establish a level of confidence that the software that has been developed is appropriate, okay, and has the quality has the quality level requested by its users and customers. Okay? But the thing is, there is a problem. Okay, nothing is perfect on Earth. I'll let you read this. So it's similar to a life insurance or a car insurance. Okay, the life insurance or the car insurance does not protect you from not dying, or does not protect you from not having accident, right? So it's similar with software quality assurance. So let's move on. So we all make errors. Okay? Every one of us. Let's make that a laws of software engineering. We all make errors. When I say we, developers, testers, okay, and managers, and customers, and maintainers, right? We all make errors. So when we develop the software, okay, the human error could eventually will manifest itself in the code, okay, as a defect, as one or many defects. So an error made by a human person may produce one or many defects, and each defect can produce one or many failure, and there are different types of failure. So I'll be showing you 3 examples from the same company, and I have nothing to say against that company. It's just that conveniently I saw those examples in newspaper. So the first example is about users of a Tesla car, about 500 users of a Tesla car that were not able to access their car. They could not get in the car because the car was locked, because there was a problem with some server somewhere. So that's a minor error. That's quite frustrating, okay? But it has no negative impact than frustration. The second level of impact is this one, is for some reason the emergency brake was activated without the driver knowing it. So imagine that you're driving a car at 160 kilometers per hour, and beside you, you have a big truck, and suddenly, as you're driving your car, your computer push the brakes or applies the brake. You can easily imagine that you could have a collision, big collision, and your car and yourself will be crushed by a big truck. And the last type of impact, in this case, again, it's a real case. It has been published in 2022, okay, where because of a software problem in the car, 2 people were killed. Okay, so this is the spectrum of impacts. So what we want to do, we want to prevent errors. Okay, because we know that we are doing errors. So let's put in place practices, measures, processes, checklists, training to reduce the number of errors that we do. Okay? But since we know that we are not perfect, we will be still making errors, and those errors will be eventually defects. So we want to detect those defects. Okay? So we are human beings making errors and producing defects. So my message here is software engineering practices like software quality assurance or software engineering standards can help you and can help your team prevent errors and detect defects. Don't forget that today you may be a software developer, but tomorrow you may be a customer of a software application with defects, and you could be impacted by severe defects as a customer of it. Okay, let's move on. So here I'm going to show you a very important graph. So at the bottom of my slide, you see the different activities, software development activities during the life cycle, starting from the left side where you have the starting of the project, then you have the REQ requirements phase, the high-level design phase or activities, the low-level design, then you have the code activity, the unit testing, the integration testing, the system testing, and eventually you're shipping the software somewhere. And on the left-hand side, you have the number of defects injected per 1,000 lines of code. So KLOC means 1,000 lines of code. So this is the definition that you can see at the bottom of my slide. So this is a unit of measure. It could be defects per age. It could be defect per function point. I don't care. In this case, I'm showing you defects per 1,000 lines of code. So this is the typical defect injection curve. So defects are, because we are making errors in each step of the process, okay, we are injecting defects at each step of the process. And for most organizations, probably organizations that you know, okay, we don't start detecting defects until we have some code, and then we are debugging the code and unit testing, integration testing, and system testing. And I'm saying, okay, that was the approach used in the 1970s. I don't know if you hear me well. I said that was the approach used in the 1970s. So 50 years ago, that was the way that people were developing software 50 years ago. Unfortunately, a bunch of troglodytes, a bunch of people, a bunch of organizations are still doing this. Okay? So what it means that we don't see the defects until we have code, and then we start testing. We start testing. And at the end, we deliver a software with partially, when I say partially tested, because we cannot fully test a large and complex software, and there are still defects left in the software, but we don't know how many you have left, because at one time, the manager will say, now it's time to ship the software. Okay? So it will be shipped with defects, but with an unknown quantity of defects left, and probably you, the customer, will be experimenting some very negative situation when your software will pop up being defective. Okay, so my question to you is what are the problem with this approach? And I'll let you think about that for a few seconds. And this is a partial list of problems. So the early defects, in other words, the defects that have been injected during the requirements phase or during the architecture phase will be detected only when you'll be testing. So it could be a few days, depending on the size of the project, a few days after the requirements have been developed, or it could be a few weeks, or it could be a few months, depending on the size of the software. If you have a large software, then the requirements development activities can last a few days or a few weeks or even a few months. And before there is one line of code available, it may take a few weeks or a few months. Okay? If you rely only on tests, you cannot detect all the defects of a large and complex software. And also, because we were not perfect when we originally developed the software, we cannot imagine to be perfect when we'll be correcting the software, right? So when we'll be correcting the defects, unfortunately, we'll be injecting another 10 to 15% of new defects. And that really leads to the concept of rework. In other words, when you detect a defect let's say, in system testing, and you understand that the problem is caused by a poor requirement definition or a defect in the architecture, it means that you have to go back, let's say, in the requirements, modify the requirements, modify the test procedures, the test cases, modify the architecture, modify the code, and start debugging, unit testing, and system testing again. Okay. So that could lead to a very unstable environment when you have dozens and dozens and dozens and sometimes hundreds of defects that are being detected. And if you don't have solid configuration management, in other words, the management of changes, then that can lead to chaos, and that can lead to frustration from developers. Okay? And the bottom line is people, that rework is a waste. We are wasting time, we are wasting money, okay? And also, most probably, the software will be delivered late to the customer, and you'll have also a frustrated customer, right? So this is my message. So the message is working smarter, okay, which may look like you're working slower, but if you're doing the things right the first time, then you will be reducing the number of defects injected, you'll be reducing the amount of rework, okay, and you'll be reducing your own frustration as well as the frustration of your customers. So let's have a look at an overview of software quality assurance. So the example I want to use is that software quality assurance is like a toolbox, and the toolbox will help you build quality software. So the analogy with the toolbox is this. is depending on the size and the complexity of software, you'll be using more or different software quality assurance practices or software engineering practices. So if you're being a house for the dog, just a few tools would be enough. If you're building a garden house, then you'll be needing more sophisticated tools and also more sophisticated competencies to build that little house. But if you're building a full house with electricity and plumbing and internet cables and things like that, again, okay, it's clear that you'll be using different tools and also a different process. Okay, the process to develop the house for the dog is not the same process as when you develop a full house. And if you are developing a medical office, then you'll be also injecting in that thing different electronic devices, medical devices that will require additional practices. And the final example, if you're building a skyscraper, in other words, a very huge, complex software, then you'll be using like those guys, and you can see a big crane. You have to use different tools to build a building of that size. Okay, so the message is depending on the size and the complexity and the criticality of the software. Okay, as an example, if your dog house is not perfectly built, if it's not perfectly square, it's not at right angle, nobody will suffer about that. The user of that house will not suffer about that. But if you're building a skyscraper and things are not perfectly aligned, then you may have very expensive problem to fix later on. Sorry. So let's have a look at the house of quality. So on what you can see is one of the things that we have are the references that we use to build software and to build software quality assurance, like standards and models and quality models and things like that. Then we have typical software quality assurance or software engineering practices like configuration management, review audits, traceability, measurement, and things like that. And here we have what I call the quality culture elements, and I like the code of ethics. And we have put the management of risk in part of the quality culture, because risk is based on the culture of the organization. There are some organizations that do not want to hear about risks. The manager will specifically say to their developer, I don't want to hear about risk. Fix those problems. Okay? Just bring me solution. Don't bring me problems. So this is what we call an organization that is risk averse. And there are other organizations that say, yes, since we are developing new product, we are taking risks. We will be making mistakes, and it's okay to make mistakes if we learn from them. So very different point of view. And all that is assured by some team, a quality assurance team, which could be with varying size depending on the size of the software. And all that is also supported by management, both by providing money, by providing resources, and providing commitment to the software quality assurance. And all that is documented in a software quality assurance plan. So the plan could be a page or two for a small project, or it could be a 50-page document for large and complex software. And all that provide a solid foundation to have stable and capable processes, continuous training, continuous improvement, quality products, and very motivated and productive employees. Okay, so today I will just touch on a few topics. We don't have time within 2 hours to talk about all of that. This is a 45-hour course. So in 2 hours, I'm just going to go over that. Cost of quality, I'll let you read that. So it's like magic. We don't have the time, we don't have the money to do it right the first time. But by some magical thing, we find money and we find time to fix the problems, okay, and redo the software. Sometime once, sometime twice. Let's have a look at the components of project cost. So there are 4 categories. The cost of execution. So if we were perfect, in other words, that does not exist, but just in theory, if we were perfect, 100% of the budget and 100% of the calendar would go in that cost category. But since we know that we're not perfect, then we do evaluation, like reviews and testings and audits. And if we are intelligent, we'll try to learn from those mistakes and put in place prevention. Okay, and this is why you're in a class right now. You are learning. You are learning from previous projects, and your professor is transmitting to you the knowledge learned from previous projects. Most of them have failed totally or partially. Some have been successful, and we have gathered this knowledge, and this is what education is. It's transferring the knowledge such that we'll be doing better software, better quality software. And yes, we will be making mistakes, but hopefully you'll be learning from those mistakes. And the 4th category, and by the way, yes, standards are one part of the prevention, because standard is documented knowledge. Knowledge documented since the 1970s, okay, as a result of failed and successful project. And we have gathered that knowledge, and I'll show you an example in a few minutes. The last category are the costs of rework, cost of correction, correcting defects, okay, fixing defects, retesting, updating the code, updating the documentation, and the cost of correction is what I call the cost of rework. And since you are software students, my question to you is, what is the percentage of your budget in this cost category? When I say budget, let's say you're doing a 10 or 20-hour project. Do you have any idea how much time you're wasting because you're making mistakes? Probably you don't know, but let me give you an example. Let you read this, and I want you to guess what's the number hidden behind my rectangle. So one of the key words here is the avoidable rework. In other words, if we were doing things correctly the first time, okay, we'll be saving 40 to 50% of a project time. Okay, so we are wasting 40 to 50% of the time, and most probably the equivalent percentage in money, because we have to correct the mistakes that we've done. Mistakes that could have been avoidable if we had been working smarter. But the thing is, don't expect things to improve by themselves. Okay? There is no miracle in software engineering. Whatever your religion is, okay, forget about that in software engineering. There is no miracle. Things will not improve by themselves. You have to work very hard to improve your process. So here I'm giving you a real example from a real company. And a few years ago, they started to measure their cost of quality. And here you can see the cost of rework, and I'll give you the numbers in a few minutes. And here you see the combination of the evaluation and prevention cost. So when they started this process improvement project many years ago, okay, at the beginning, they measured the cost of rework, and it was 41%. Okay. For your information, Raytheon is an engineering organization working in the very high-tech domain. So it's not a bunch of guys developing apps or games. Okay? It's a bunch of engineers working on developing very sophisticated technology. So even that, back when they started, they had 41%. But the good news is, as they invested in evaluation and also most importantly in prevention measures, then the cost of rework went down, down, and down. Okay, so the message here, if you don't do anything, okay, you'll get that 40 to 50% of rework. But if you put in place prevention measures like training, methodology, tools, and standards, then if you do it right, then you'll get the result that I'm showing here. And I'll give you an example in a few minutes about that, real example. So when I meet companies, okay, I ask them that question that I asked you a few minutes ago. I say, oh, are you the project manager? I say, yes, I am the project manager. And I've been managing projects for many, many, many years. So in other words, he assumes, or that person assumes, that that person is a very competent manager. Then I ask that manager, please provide me with the numbers, the percentage for those 4 cost categories. And the one that I'm mostly interested is the cost of rework, non-conformance cost. And I would say 99% of the developers and managers that I've met during the last 25 to 30 years, I can count on the fingers of one hand the number of managers that can say, yes, we have those numbers. So if you don't have those numbers, don't tell me that you're really managing a product development. Okay? Because 40 to 50%, you're wasting 40 to 50% of your budget and your schedule because of the work. Now, also, most managers that you will be meeting, they will tell you, oh, we are doing very quality software. Our product are top quality. We are building quality products. Okay? Now I asked them that question. I said, please provide me with this information. Can you tell me, for each activity of your process, the average density of defect injected, the average density of defect detected, and the number of defects delivered to your customer? And again, I would say 95 to 98% of the managers that I've been talking with, or the software developers that I've been talking with around the world, cannot provide me with those answers. So you have an opinion that you are developing quality software, but you have no data to demonstrate it. This is not software engineering. You are an artist. You're managing a project like an artist, and you're developing the software as an artist, working with a bunch of artists. Sorry for you guys. Okay? But if you are working like a software engineer or software engineering manager, then you should be able to provide me with the answer to the questions on this slide. Otherwise, okay, go back to school. So let's have a look at one other part of the House of Quality, the policies, processes, and procedures. So you can see the pyramid on my slide. So at the top part, you have the policy. Why are we doing things? Then we have the processes. What are we doing? Who is doing what, and where in the development cycle? And then you have the procedures. Procedures are how to do things in detail. And at the bottom, you remember the definition of quality and quality assurance. You need evidence. So the proof of execution are the quality records. So why are we doing this? Remember, I talked to you about having performant processes and capable processes. So here on the left-hand side, coming from the bottom to the top, at the bottom you have a process which is invisible. Okay? You're putting resources in, and there is some magic that happens, and after a few days or a few weeks, out goes some software. Okay? And this is a non-documented process. Okay? And as you put in place practices, then you document your process, okay? You measure your process, and then you measure the activities of your process, and you measure the tasks of your process. And as you have data, okay, because you're collecting data, okay, then now you know the quality of your process, the quality of your product, and then you can make wise decisions to improve both the process and the product. Sorry, I have a cold because I told you that it is winter here. So in winter, we have cold here. So the other side of my slide is what I'm showing you is the process capability. As you improve your process, you are more and more able to have better estimates, meeting the estimates of schedule, meeting the estimates of time, meeting budget, and also meeting the estimate of quality. So as you move up, you have higher visibility and higher capacity, and that means that you increase the accuracy of the estimation, increase the productivity, and reduce the gaps between the estimation and the actual. And also, I should have put, you also improving the quality of your product. Okay. Why am I saying this? Because if you want to increase productivity, that's very easy. Very easy to increase productivity, but you may do that and you may lose quality if you go too fast. Okay? So the secret is this. Okay? And I'll give you a real example. The company is called Siemens. It's a very, very big company located in a European country. And they have a dashboard with 6 different measures. So customer satisfaction, they measure cycle or development cycle time. They measure the productivity, the process maturity, the quality, and the technology that they are putting in place in their organization. Now, as I said, if you want to improve productivity, that's quite easy. But you don't want to improve productivity and lose quality. So that's the bottom line. Okay. Very difficult. Okay. You have to make sure that if you want to improve, let's say, productivity, that you maintain at least the same level of quality. And hopefully, okay, you should be also aiming at improving the quality without losing the time to develop software. Oh, that's quite complex. I agree with you. That's not easy, but the bottom line is if you don't have measures, how can you know what to do and what to put your money and what to put investment to improve the process and the quality if you don't have solid measures? And for your information, I didn't put the date, and I should put the date. Sorry. Oh yeah, I have it on my. Sorry, I have it on my desk. So this is a presentation that I attended many years ago. I would say in 1998. Okay, so that's quite a long time ago. So in 1998, Siemens made a presentation that I attended with that slide. So imagine where they are right now. Okay, so since 1998. A lot of things happened to improve the process, productivity, and quality. So let's move to another part of my presentation about software quality models. So ISO has developed a series of standards about quality. The series is the 25,000 series. And probably your professor told you about this standard. But just for information, as you can see at the upper level of my slide, from the left to the right, that you have as part of the quality model, you have the functionality, the compatibility, the capability, reliability, security, maintainability, flexibility, and safety. And those are high-level quality characteristics, and each of those quality characteristics is supported by sub-quality characteristics, and each of them has to be defined in the requirements, and each of them also has to be measured as you develop the software, such that when you deliver the software to your customer, you not only deliver the functionalities required, but all the functionalities with all the quality characteristics required by the customer, and you can demonstrate that you have delivered the level of quality asked. And for your information, that's the thing that is important. So developing functionality is easy. This is this is good for students, okay? But when you talk, if you want to talk as a software engineer, you have to go one level up and you have to develop all the functionalities with all the quality. So very different challenge. But there is hope. There is hope. An organization in USA, a consortium called CISQ, has developed a tool to develop to measure automatically those 4 quality characteristics. In other words, you can specify in the requirements with numbers. Okay, you can specify for those 4 quality characteristics, let's say the maintainability or security, what the customer wants, and the tool developed by this consortium will automatically measure if you have achieved the value asked by the customer. So this is where we are right now in the development of quality in software engineering. Let's move on now to another part, reviews, and I'll let you read that text. So reviews, we could review everything. By everything, I mean you could review a plan, you could review an architecture, you could review the requirements, you could review your test plan, your test procedure, your test cases, and also you'll be reviewing your code, right? And this is the good news. In other words, you'll be learning from your mistakes and you'll be learning from the mistakes of others. So it's like accelerated learning, and I'll give you data in a few minutes. Now, I'll give you a real example of a real company called Northrop Grumman. Again, it is a high-tech company, and you have at the bottom of my slide the typical development activities, and on the left-hand side, the percentage of defects that have been injected during the different development activities. This organization is using the waterfall approach, but if you're using another software development approach, that's the same principles apply. Okay? So here, what I want to point to you is 49% of the total defects have been injected in the requirements, and another 20%, in this case 21%, of the defects have been injected in the architecture, preliminary design and detailed design. So if you do your math, okay, so you have 49% plus 21%, so 70% of the defects have been injected before one line of code was written. Remember the slide that I showed you before, where stupid people start detecting defect only when code is written? Now you can see how stupid it is. Okay? Because you cannot, with a test, you cannot detect a requirements defect directly in the requirements document. Okay? You cannot test if you have a defect in the architecture, okay, with the tool, okay, unless with testing, with the testing like you used to do. Okay? With other type of tool, I'll show you later. Yes, you can. So the message here is, since you are injecting 70%, and most probably that's a typical pattern that applies to many organizations. Okay, since you are injecting a high percentage of defect before one line of code is developed, so why do you wait until you have functional code to identify those defects? So the good news is the same organization has put in place processes like software reviews, okay, to detect defects on the spot. So if you look at the requirements bar, it says that 96% of the defects have been detected. What does it mean? It means that during the weeks or the months that it took to write the requirements document, in this case, since it is an aerospace company, most probably it's a large document. of maybe 50 to 100 pages, maybe 200 pages, but whatever. They have detected, let's say that they have injected 100 defects in that document. With their process, they were able to detect 96 of them. Okay, why not 100%? Again, nobody is perfect. Okay, so but 96% is fantastic. It means that only 4% of the defects will get into the other stages of the software development, and eventually it will also be detected by the other software reviews and in the process. Okay, so this is my question: how do you obtain a high percentage of defect detection and correction? Part of the answer is have a robust process, okay, with reviews, okay, lots of reviews, okay, and a culture and a budget and a schedule that allows you to do things right the first time. Okay, the analogy between reviews and water is this. Imagine you have a water with a lot of bacteria, which is typical of any river in the world. So what you put in place, okay, at each step of the filtration, okay, you put in place filters. Okay, you start with big filters to filter out the big components, and you measure, okay, how many things you have detected, and you put in place smaller filter, and even smaller filter, okay, and you measure at each step of the process, and eventually you can make a decision, okay? It's not an opinion, it's a decision that the water that is outputted at the end of this filtration cycle is drinking water, safe drinking water with a known level of bacteria left, okay, but that are not dangerous for the health of the user. Okay? This is what we do with the water that you drink every day. So it's roughly the same process that the company that I showed you before is doing, putting in place a process. This is what you see, and putting in place a lot of filters like software reviews, software testings, and things like that, checklists, document templates to get the defects out. Now, I'm going to show you a slide. Please make sure that you don't fall from your seat, okay? Because this is quite a surprising slide. So what you see is at the bottom, the inspection rate, number of pages per hour, okay? And on the vertical axis, the number of defects detected, okay, in the document. So as you can see, if you go on the bottom right-hand side, you have the number 14. Okay, so if you read at a rate of 14 pages per hour, you detect almost no defects. And as you slow down and as you reach between 2 to 4 pages per hour, then you start to detecting more defects. And then as you slow down at about 1 page per hour, then you can see that the number of defects goes to the roof. Okay, goes very, very high. Okay, now we are not inventing defects. We are detecting defects. So when you read too fast, it's like you're reading a newspaper. When you're reading at a rate of about 1 page or 2 pages per hour, it's like when you're studying a textbook. When you are studying, okay, you are studying at a slow rate, okay, because you want to understand what you're reading. You want to make sense about what you're reading, okay? And this is what is happening in reviews. When you slow down, this is when you discover the hidden defects. The defects that you cannot detect when you read, like the speed when you read a newspaper. Okay, the other good news, and this is for you also. So again, okay, slower is better. Okay. Now, this is an example from the Swedish company called Ericsson, okay, located in Stockholm, in Sweden. And this is an example of one software developer, a curve of one software developer. And what the curve shows is for the same developer developing the same type of document. Let's say that person is developing either the requirements or the architecture or the test cases or the test plan, whatever. The number of defects that have been detected, okay, goes down drastically from the 28 to 25 and eventually to 3, 4 defects per page. Okay? So in other words, what this slide shows is by doing reviews, okay, by having a good process, okay, you're learning to inject less defects because you are learning from your own defects, your own errors, okay? And the next time you write the same type of document, your brain remembers the type of errors you did the last time, and your brain will automatically process that information such that you make less and less and less errors. And this is a real curve from a real company. Now, let's look at another company producing very sophisticated equipment, in this case, jet engine. Okay? And I met those people a few years ago. I was presenting 29110 standard during the conference, and the people from Rolls-Royce were presenting this. And I asked them if they could send me their slides, and I want to show you or share with you something. Okay, so here on the left-hand side, you have the defect injection for 6 different developers. Okay, now remember, you are in a real company developing real product like the software that controls the engine, a jet engine. Okay, so you can see that there are people like developer A that inject about 0.5 defect per 1,000 line of code, and at the bottom you have developer F that inject 18 defects per 1,000 lines of code. So you can see a very large variation. Okay, a factor of 30. I say again, a factor of 30 between 0.5 and 18 defects. Okay, same team. Okay, the people working in the same team. Now let's move to the second part. on the higher part, it's the reviewer effectiveness. So remember, some people are more agile, have more qualities to detect defects, and some people cannot see the defects. Okay, so here you can see that developer C has a defect effectiveness of 94%. So it means that developer can detect 94% of defects in a document. And if you look on the other side, developer F, that guy has only a 30% defect identification rate. In other words, it can detect only 3 defects for every 10 defects injected. Now imagine the difference, and again, a very large variation, a factor of 3 here, okay? Now imagine that if you are working with developer A versus developer F. So developer A inject a very, very, very small number of defects, okay? And developer A also has a high level of defect removal effectiveness of 75%. But if developer A is reviewed by developer C, then there is almost no defect left in the document. And if you go at the bottom of my slide, then if you have developer F that inject a lot of defects, that reviews his own document, since he has only a 30% defect identification effectiveness, then he will have at least 12.6 defects per 1,000 lines of code left in his product. So here what it means is you have to identify in a team who are injecting defects and who are best or worst at detecting defects, and to assemble a team that will identify as many defects as possible. So remember this curve. Now you are putting in place software reviews like software inspection, and this changes everything. Okay. When you start software reviews, you're not perfect, so you're not detecting 100% of the defect, but it's much better, much sooner. As you can see, you can detect and correct the defects right on the spot. Okay, and eventually, as you deliver your software, most probably your software will be delivered earlier than if you're not doing reviews. And also, you know the gap between the number of defects injected and the number of defects detected. You can estimate with data, okay, with your own data, okay, what is the percentage or number of defects left in the document or in the software. So this is what I call software engineering. Okay? You're not a bunch of artists. You are working like engineers. Okay? So you should be using reviews. Okay? Again and again, you should be working smarter. So let's move to another part of my presentation about standards. And I want to stress again this. Standards are codified knowledge that we have documented as a result of our learning of a failed and successful project. And I will skip a few slides because I don't have, we're losing time. So here, what I want to show you is the organization in ISO. There are many committees, and there is a committee responsible for the development of software and system engineering standard. It's the subcommittee SC7, to which I belong. And for your information, they have published so far 215 standards, and another 39 are in development. And there are about 60 countries participating at different levels to the development of those standards. Sorry, and those are you can see the map of the country in blue. In blue are the active members, and in the orange or whatever color you see on your slide, those are the observing members that have that do not vote but participate to the development of standards. Just for your information, when I participated, as I said, I've been a member of ISO since 2002, so over 20 years. Just to tell you that ISO do not pay experts in working to develop standards. Cool. So this is the curve. Remember, I told you that we were developing standards to improve the software and systems, and you can see since going back to the 1990 something, that the number of documents, the number of standards have been augmented a lot since then. Okay, we went from about 50 standards to about 200 standards. Why? It's because we are learning. Why? It's because software are getting bigger and bigger. Why? It's because software are getting more and more complex. Why? It's because more and more software are becoming critical. By critical, I mean if they fail, okay, they may cause damage, financial damage, environmental damage. They may hurt people and they may kill people, right? So this is why we have more and more standards. But again, let you read this. Sorry, we cannot guarantee the output. We cannot guarantee. We can only improve the confidence, okay, that you will be getting better product, okay, with meeting the quality, budget, functionality, objectives of the project. That's the best we can do. And it's going to be like that for the next couple of years. Okay? Most probably, and we are experimenting with this right now with a colleague. We are working, doing some experiment with ChatGPT, and we have a very surprising, fantastic success in producing very high quality documents. But I'm not saying that to tell you that the miracle is coming, okay? But there is hope that we could have one day an invisible partner that will help us develop better quality products, maybe faster also, as we learn to use that thing called AI. So what I want to show you is we have standard that covers everything in software engineering. We have standard that defines the vocabulary, the terminology that we use in standards. We have body of knowledge like the 3 buck. We have life cycle standards. Life cycle standard means it covers all the development activity, all the activities from the time that someone has an idea for a product and to the time that you develop the product, that you maintain the product, that you operate the product, and eventually after a few years or a few decades that you retire that product and you replace it with another one. This is what we call life cycle. And 29110 is part of that, and I'll be talking about that in a few minutes. We have standards about documentation, a standard about requirements engineering, standards about architecture, a large family of standards about testing, 29119 series, standard about maintenance, about project management, about risk, about measurement, about quality, and about size measurement, and a bunch of standards about tools. So my message is you have standard that covers everything that you as a software developer, or you as a software manager, or even you as a future customer, okay, would use to get or develop a better software. And there are many advantages to software standard, and I'll let you read them. Well, you have no reason. I say again, you have no reason to ignore standards. Okay? They are your friends. Okay? Learn about them. Learn and ask your professor to teach you how to understand them, how to use them. Because a standard by itself is useless. Okay? It has to be implemented. It has to be implemented in a software process. Okay? So the knowledge captured in the standard is documented in a software engineering process such that everyone can use it, okay? Without having to refer back to standards anymore, because the knowledge of the standards have been put in place in the software process, in the software templates of your project, or in the checklists and in the training, okay? It's embedded. Okay, so now let's have a look at 29110. So 29110 is one of the life cycle standard, and my working group has been established 20 years ago. We are going to celebrate this year the 20th anniversary of my working group. The flags and logo that you see are the countries and professional organizations that are working with my working group to develop and improve the 29110 series of standards. So what we have developed for you a roadmap, because nobody is perfect to start with. So we have developed a roadmap starting with what we call the entry level for startups and for very small projects, 6-person months project. And then we have developed the basic profile guide for an organization that has one development team developing one product at a time. And there are some organizations that are bigger, that have more than one team developing more than one product at one time. And also we want to make sure that we want to help VSCs to be competitive and stay competitive and grow in the world. So inside our process, inside our guides, we have at least, okay, we have those two processes that are the foundation of each of the guides, each of the parts of the roadmap that I showed you. There is a project management process and a software implementation process, or we could call it a software development process. So as you can see here, it's like the gears of a clock or the gears of an engine or a machine. It means that they work together. And my question to you is this. Why am I asking this question? Because many people will say, why do we talk about project management in a software engineering standard? Software engineering is just a technical challenge, is only technical activities. And we're saying, no. Okay? You need solid, good project management to eventually develop good functional software. So the reason for that is this. And the example I'll give you in a few minutes will demonstrate that. So the guides provides you with a minimum number of tasks such that the customer will get what he wants with no bad surprise. And by minimum, I mean this. So the analogy of cooking, let's say a chocolate cake, if you remove a step in the recipe, or if you remove an ingredient in the recipe, you will not get the same chocolate cake as if you were doing each step of the process and having all the ingredients required by the recipe. Same thing in software. So let's have a look at the inside of the guide. So the message here is, unfortunately, okay, the main outcome of a software process is invisible. Okay? The code is invisible. So what we need to make visible the process that develops that. Okay? To make sure that at each step of the process, we make visible the documents that are used and developed at each step of the process, such that eventually we would have good quality code that will be sent to the customer. So here we have a customer that knocks at the door of a VSC with some list of functionalities, with an agreement or statement of work. And the management of the VSC says, okay, yes, we have the competence, we have the time and the resources to do this project. Yes, we will do this project. You sign a contract. And then first thing that is started is the project management process, where the first activity will be the planification of the project. So project planning. Once the project plan is approved, then you'll be using the project plan and you'll be executing the project plan. And what are you going to be executing? You will be executing the software implementation process, which will start with what we call the implementation initiation, which is typically a kickoff meeting where the team leader will explain to the working members of the team that a new customer asked us to deliver such and such a project with such functionalities, and we have a calendar time and et cetera, such that everyone is on the same page. So this is a meeting that lasts, 15, 20 minutes to make sure that everyone knows what it has to do, the role of everyone, and then you do the typical technical activities of a process, software engineering process, and as you perform those activities, you evaluate the progress of your project against the plan, okay? Because you have planned and you have a calendar, okay, with the list of things that you deliver to the customer. So you want to evaluate if you are within budget, within calendar, and eventually, okay, you finish your product and you deliver your software to your customer. And by software, what I mean is not only the code, but whatever the customer asks you, like a user guide, maybe an installation guide, maybe the user or the customer may want you to give you training to your employee about the new software. So this is what we call the total software product. So what we have in the two process, we have embedded different quality assurance activities, or tasks, I should say. So to make it simple, we have two processes, project management and software implementation, and each of them, we have put a few tasks to assure that you will have a quality product at the end. So my question is, why are so many developers and managers are still using an invisible process to produce an invisible product, while there is a process which has been documented and has been published over now 14 years ago, and is available free to be used, and it's also translated in different languages. So that's stupid. That's stupid not to use proven practices documented in a standard which is freely available and translated, right? Just one word, even though I've showed you what looks like waterfall, it's just for presentation purposes. You can assemble those activities and tasks using the life cycle that you prefer. If you want to work in agile or incremental, then you can assemble those blocks, like see them as Lego bricks, that you can assemble them for the life cycle or the development cycle that your customer wants. Now let's have a look at inside one of those activities, the requirements analysis activity. Each activity is composed of a series of tasks, and I'm going to show you one task. And this is exactly what you will see in the guide. It is a copy and paste from one of the guide. So on the left side, you see that two people are involved, or two roles are involved in this task, the customer and the analyst. And the task here is to validate and obtain approval of the requirement specification. And here we have some text that explains in more detail what it is. And to do that, the input documents that you need is the requirement specification that has been verified. By verified, I mean you have conducted some review, some walkthrough or inspection to remove all the defects, all possible defects that you have identified, such that you have a high quality requirement specification that you can present to your customer. And at the end of that review, then the output will be the requirement specification that are now validated, because they have been approved by the customer. And also you have a document that's called the results of validation that I'm going to show you next. So as you can see, it's like a recipe, a cooking recipe with what has to be done, what ingredients you need, and what will be the next step and things like that. So the output is this document. And when I say document, it doesn't have to be paper, right? It could be an electronic document, it could be an email. So here the document says this is what you should include in this report to make sure that eventually, if thing goes bad, if you have to go in court, then you can remember the word evidence, the word proof, that you can show to the judge that you have the evidence that the customer participated to the approval of the requirements, such that the customer cannot say that he didn't know that, or this is not what he wanted, right? Cool. So let me show you briefly 4 examples of successful projects that have successfully used 29110, because later on I'm going to show you a counterexample. So here, a startup in Peru, 4 people, 880-hour project, working in agile mode, 6 sprints with a percentage of rework of 18%. Another small, very small organization developing cosmetics, 1 developer, small project, 12% rework. Another startup, okay, almost 1,000-hour project, 2 developers, 12.6% rework. And I told you that a VAC could be a small team in a large organization. This is an example. Very, very large organization that is providing electricity to 8 million people here in Quebec. And the IT division has 2,000 IT people supporting 2,000 applications. But there was a team of 11 people that had to develop some application. The project was 1,500 hours with using basic profile with Scrum, and they had 9.6% rework. So remember the curve that I showed you before, that I just demonstrated to you. The Peruvian startup 18%, the other startup 12%, the cosmetic company 12%, and the utility provider 9.6%. And this is the message. So you have the choice. You reinvent the wheel, you do the same mistakes that people have been doing in the 1970s and the 1980s, or you use proven practices from software engineering, from software engineering standards that have captured how to do things correctly, and instead of starting a company or having a company that has 40 to 50% rework, then you can go down to the 10%. And remember one thing, that was the first project done using that document. So you can easily imagine that the same organization that would use the same process for a second project or a third project would even lower that percentage of rework. Because as you do over and over new projects, you're learning from your previous mistakes. So the 9.6 or the 12% or the 18% will go down like the same way that it went down from Raytheon from 41% to 5%. Okay? So for those of you, and again, those are freely available documents that are available to you as students. Okay? Now, if you're developing systems, and by in 29110, systems are composed of software and hardware component, we have developed the similar roadmap as I showed you before, and very similar guides. Okay? And the only difference is on the right-hand side, instead of working at the software level, you're working at the system level. And when it's time to do the construction of your hardware, let's say building, casing, cabinets, LANs, or computer boards, or telephone, and software, okay, you use 29110 for software, and you build your systems like that. If you want to know more, with a colleague, I've published a book in French and English about doing systems engineering with 29110. Okay, that's all I want to say about that. Now let's move on to the real company that ignored the practices of software engineering standards. And I will be repeating a few things just to make sure that you notice them, because they are important. So this has been published now 2 years ago in May 2023. So probably your professor has access to it. If not, it will be a pleasure to send a copy to Sandra, but I think I sent her a copy a few months ago. And this is what happened. Okay? So the objective of this article was to explore what went wrong in that real project that I will explain to you. Explore, so what should have been done, okay, to avoid the mistakes, okay, not to make the same mistake that have been done before. What were not the objective of the project was to ridiculize that organization, because don't forget, 99% of organizations are users of software. Okay? They're not developers of software. They're not software engineers. They are not software experts. They are experts in their domain. They sell product. They give you product or services in a bank or in a government organization. So for them, software is a tool. Okay? They have no expertise in documenting sophisticated software requirements and quality characteristics, because this is not their competence. Okay? This is not why they were hired. So the background is that small organization was providing services to 400 customers and also was providing paid services to customers. But again, this organization is a software user, so I call it a naive organization because it has no experience in development. It didn't know how to select the best software developers, okay, and because it doesn't know anything about software development, that company, that organization was trusting the developers because they didn't know about software development, and they had no expertise in managing software supplier because this is not, again, their job. Their job is to provide services to their customer. So let's go inside that thing. So the background. So to protect that company, I'll call it Acme. Okay. So when they evaluated the different software supplier that can develop that software, the selection team noticed two important risks about the organization that was selected to provide the software. And I'll explain to you why in a few seconds. So they noted two weaknesses, and they were web design and user experience design and user interface design. So if you know something about web design for users, you should come up to the conclusion that doesn't make sense, because those should not be weaknesses. That company should have high level of expertise in those two domains. But as I always say to my student, life is a bitch. So even though what seems to be rational, sometimes very irrational things happen. And I'll show you why in a few seconds that happened. So those two weaknesses are, in software engineering terminology, risks. Okay? And I'll show you why in a few minutes. So let me show you, I told you that Acme is a naive user. So this is the request for a proposal, and I'm not inventing everything here, anything. It is a translation from English to Spanish of their request for proposal as is. Okay, so I'll let you read this. So you agree with me? That is quite naive, but that's the best they could do. Okay? They're users. So the other part of the request were about the costs, the list of functionalities, and as you can see, they are described at a very, very high level. Okay? You don't see any quality characteristics there. Okay? So the message is that. And this is what you'll be facing for the rest of your career. Naive customer, most of them, naive customer that want software as a tool for them. And the last thing that they wanted some certification that the website would belong to Acme. Okay? And you'll see later on that you can put that on a contract, you can sign it with your blood, but strange thing can happen. And again, I will say, life is a bitch. So even you have a good contract signed in front of a lawyer, even though you had a judge that would sign the contract, I will show you later on that even though you have that certification, you may have a bad surprise. Okay, so one thing that you have to notice is only one item will be delivered to the customer, to Acme, the website. And when I say delivered, because I'll show you later on, the software developer will be hosting the software. So in other words, it will not be physically delivered to Acme, but it will be hosted on the website of the software developer on behalf of Acme. So one potential supplier submitted a proposal also, okay, but it was more expensive, okay, 50% more expensive, and that supplier had high expertise in exactly the two weaknesses of the supplier that was selected, right? Again, sometimes you will see very strange things happening in the business or in government organization, and that's an example, okay? And you'll see later on that if you pay less, okay, because you have hired a less experienced developer, eventually at the end you will pay more, okay? It will cost more than if you had hired the right guys. So the reason why, this is what explains why that supplier was selected, because it already had a content management system that was identical or very similar to the one that was needed for Acme. So Acme management says, oh, so that's great. It means that we won't have to pay to develop another content management system. So the contract will be less expensive, and this is why they selected this software provider. But, and there is a big but, okay? There is a risk. Okay? There is a risk that Acme is trapped with this with this supplier for many years because it is using a proprietary software. So if tomorrow you decide to say to that developer, oh, please send me the software for the website, and I'll be using another software supplier, the original software supplier will say, sorry, no, because the content management system belongs to us, and you cannot send it to another software supplier, right? So this is why you'll be trapped. Okay. So the new project manager that was hired tried to use 29110, but unfortunately, when he arrived at the company, at Acme, the 29110 was not cited in the request for proposal, and the people from Acme were reluctant because they didn't know about 29110. So they said, no, we won't bother about 29110. Manage your project and don't use that. But the new project manager decided to use 29110 just to compare what was done by the software supplier against what was requested by 29110, and this is what I will be showing you in the next slides. So what is requested by 29110? So it says that Acme, the customer, okay, will, and here we have the provider of the software, okay, is normally Acme would write a detailed statement of work or detailed agreement. Okay. Also, it means that a project plan would be developed by the supplier and also approved by Acme. Okay. In 29110, we said that we don't want bad surprise for the customer. So the customer has to review the plan to make sure that everything is in there, that he agrees with the calendar, and he agrees with the budget, and he agrees with everything. Okay? So this is what is happening. And a plan also lists all the work product that will be delivered at the end of the project. So a user guide, implementation guide, or whatever. Also, the requirements are developed by the supplier and approved by Acme. Remember the validation task that I showed you? Again, we want to make sure that there are no surprises. We want to make sure that the supplier understood everything, okay, and that the customer, Acme, agrees with the list of the things that has to be developed. So again, no surprise. We don't want bad surprise. Also, the supplier should have identified the quality characteristics specific for that project. Also, the requirements and the design and the code should have been traced between each other up to the test, and I will show you what it is if you have not learned what traceability is in a few seconds. And also, there will be an evaluation against the plan, let's say after a month or so, to make sure that we are on track and there are no bad surprises and things like that. And also, there is an acceptance of the software by the customer at the end, and eventually there is a delivery of all that was requested by Acme at the end of the project. Okay, so this is what 29110 roughly is saying. Now, what happened is this: is the supplier has developed a 2-page proposal. Now that's quite small, right? And that in those 2 pages, there were the main tasks and the cost on those 2 main tasks, and also please note that part of the costing was that the provider says they will be hosting the website, which makes sense, right? Because again, Acme is a user, so they don't know how to host a website and things like that. And also, part of that supply proposal is the calendar, 6-month calendar. Now you note this. If they had been using 29110, the supplier would have had to document that. And naturally, part of that would have to be approved by the customer. But life is life. And also about the project planning, the request for proposal and supplier proposal were said by the one of the member of Acme that there was no need to develop a detailed project plan, that the 2-page document was enough. And also, please note that the supplier did not list documents that should have been developed and would have been delivered to the customer. Okay, so no documents will be delivered to Acme. And part of the agreement that 29110 is asking is some product description of the scope, the objectives of the project, and also the list of products that will be delivered. By products, I mean the documentation, the user guide, maybe an installation guide, and also, naturally, the website. But unfortunately, that document was not sent to the supplier, because the marketing director of Acme said, no, we don't need that. Again, don't forget that Acme is a naive user. So for them, they say, no, we don't have to bother with this. Let's the supplier do its job. We don't have to do that. So here we have the case of a non-technical manager, because the guy is a director of marketing, that interfered with the process which he had little or no knowledge. His expertise is in marketing, not in software development. So he should have left his project manager that was hired for that to do his job. But again, this is what happened in real industry, real life. Now, let's have a look at what has been done. All projects have risks. This is, I would say, another law of software engineering. All software projects have risks during development. Okay, take this for granted. Okay. Now, if you know that, then and if you remember that, then you'll be reacting accordingly, and you'll be looking at risk during a development project. So what happened? And for information, 29110 will help you by providing a few tasks to help you identify the risk, document the risk, and eventually monitor those risks to address those risks. But unfortunately, neither Acme nor the supplier assessed the risk at the beginning of the project. Okay? If they had used 29110, they would have to part of the project plan, because here that task is part of the project plan, is to identify the risk such that the owner of Acme, okay, the manager of Acme would have said, oh, we have a risk here. So how can we reduce this risk, okay, such that we don't have a negative impact about this risk? But since that wasn't done, then the Acme, for them, there was no risk. Okay. So changes again. Almost another law of software engineering. All software projects have changes during development. Okay. So to help you, 29110 provides you with a template that will help you to identify the changes and assess the impact of that change before saying yes or no, the impact on the schedule, the impact on the quality, the impact on the budget. Okay. And in this case, this is how it was done between Acme and the software supplier. Change were sometimes discussed on the telephone, sometimes it was in an email, or sometimes it was through the project management tool. The problem is, okay, if there is a conflict, if there is a problem somewhere, a telephone conversation cannot be used in front of a judge to demonstrate something unless you have a witness. So what 29110 says, please document what has been discussed about the change. It could be a short email, 3-sentence email saying, okay, we discussed about the change and we made that decision. Okay. Now I see that people are leaving. Should I stop my presentation now, Sandra?
We can maybe jump to the conclusion. Sorry about that, because they have another class coming up.
So I should stop there?
Yeah, if you can jump to the conclusion, that would be great, please. Can you hear me?
Okay, yeah, let's go to the conclusion. But before I go to the conclusion, I want to make one point. Let me go to my slides. So I have 5 suggestions for you, okay, before you leave. I want you to make sure that because you have to select, if you select a job that you love, you'll never have to work in your life because you'll be having fun. So you have to find the organization that will provide you an environment where you will be doing professional work and you'll be happy about the work you do. So the evaluation of the quality culture is an important part when you're looking for a job, because quality culture means that's the way we're doing things here. So I'm suggesting to have in mind those 5 things. Select an organization that is already using a documented process. Okay? So you may ask the people that is interviewing you to show you their process. Okay? Because you want to make sure that it's not only blah blah from the person that is interviewing you. You want to make sure that they have a real documented process. Select a process that is doing reviews like software inspection, because it's not a waste of time. Select an organization that is already improving its process and tools and training. Select an organization that is already measuring its process and the quality. And select an organization that will allow you to learn from your errors. Okay? So my question to you is, why not select an organization that meets your values and career goals? Okay? And why invest in an organization that will not allow you to increase your satisfaction and your value on the job market? So the conclusion is there is a wide spectrum of proven practices. Software quality assurance can help you in providing quality product. We have developed 29110 to help you, okay? And everyone should be learning about software engineering standards and software quality assurance. And my last word is this. So it's up to you if you want to be a wise man or a fool, right? So that's the end of my presentation, even though I remove about 15 minutes or so, the time that we wasted at the beginning. But again, life is a bitch. So thank you very much.
Thank you very much. Thanks.
Okay.
Okay, chicos, pueden seguir.